Okay, today we're going to be talking about section 11.6, which is natural logarithms. I had my son ask me when he saw he was writing about natural logarithms, he says, is that like organic, logs? And it isn't. It's kind of organic. We'll talk about exactly where we get logarithms. Logarithms are probably a little thing you've seen on your calculator for a while, so you can see our picture here. It's usually next to your log key. On the graphing calculator, it's below the log key. And we're going to be talking about how we can use these natural logs to evaluate expressions, and we're going to solve equations that instead of logarithms, and I think I have this wrong, using natural logs is what we're going to be using here instead. So we'll talk about what natural logs is. Natural logs came about, well, first of all, we should talk about, when we talk about this natural logs, and natural logs, you think, okay, that's NL. But then when you look, here on our keyboard, it's shown as an ln, and the abbreviation of natural log is ln, not nl, and you might ask yourself why. The y part, there's actually a lot of not controversy, but different opinions on the y. One of them, and probably the leading one, is that natural logs was actually thought of as the Latin word of natural log was log natural. And so that's why ln was for log natural. And so it was just kind of a different way. In another language, they had ln instead of nl, and we never switched it into our language. And there's also some other questions. There's a theory that it was supposed to be like lg, but then someone somehow thought this g was an n, and so it came into ln. And so a lot of different theories abound. We got E. When we first talked about E, we talked about the number E in a previous video. And we said that really came about when we had so many financial equations, and then we always found the same ratio where when you had things compounded continuously, you always came up to that value of E, and it was, if you remember, 21718. I think I'm memorizing, I think it right. It's something like that. So it's this number that's a number. So that's what E is. What we came up with for natural log is over and over again we had problems like this where you had e to the x equals 15. And so we were solving it by saying, well, then x must be the log of 15 over the log of e. Okay? And there was a lot of different times where we had a log and the base was e. So basically, it came up the fact that we can replace log base e with natural log. So log base e is really natural log of x. All right. So when they say here, what is the log base e of 14? The answer is that we're looking for what is the natural log of 14. When we're asking here, what's the natural log of 28? This is where I'd say to you, oh, I need you to use your calculator. This is in exact terms. If we want to estimate or we want to round an answer, all right. So if you ever want exact, you have to say it in terms of log, exact. Okay, but if we wanted you to round the answer, we would have you say in here, and it was natural log of 28. So I just put in my calculator, what's the natural log of 28? 3.332. Sorry, trying to find everything here. So that was 3.332. That was our natural log. Anti-log, well, it's a lot like natural log. I apologize, I said it wrong. It was a lot like anti-log, where we're taking the inverse of our natural log. Well, the inverse of our natural log is e. E and natural logs are inverses of each other, and they kind of undo each other, I guess is a good way to say it. So really, the anti-log is e to the 2.34. The anti-natural log, sorry, of 2.34 is e to the 2.34. So when we're doing that on our calculator, we would say what's second? Natural log, which is the inverse, which is e, and it was 2.34. And our answer there was 10.381. Okay? So we would say, well, our answer is 10.381. All right, so then we have all these different things that we're solving for. First of all, when we're solving for x. Well, usually what we do when we solve for x is we take the natural log of both sides, or the log of both sides. So if we had the log of e to the x equals the log of 47, and then we'd have the x come out in front, and x would equal the log of 47 over the log of e. Well, the log base e of e, and these are the log base 10s here, that we're talking about. But if I wanted to say, well, if I did the log base e of e, like I had a little e here, then this would be a 1, and I just have to figure out what the log base e of 47 is. Well, the shortcut is the log base e of 47 is the natural log of 47. And then I can look at that on my calculator fairly quickly. Natural log of 47, and I find my answer is 3.85. So then my answer here is 3.85. Okay? So we can kind of come up with our rule. Our rule is that the exponent with the base of e equals the natural log of the value on the other side. So in this case here, the 3x equals the natural log of 18. Now if I'm solving this for x, I would just divide both sides by 3, and my x really equals the natural log of 18 divided by 3. Now in a technicality, you could say, hey, I'm right, that's exactly the right answer. Alright, you could also find an estimated answer by saying, what is the natural log of 18 divided by 3? And say, well, the estimated answer is 0.963. So I'm going to be okay if you say it's 0.963, or if you leave it as natural log of 18 divided by 3. All right, both of them are really good answers. Both of them show the right answer. All right, one of them is exact, one of them is an estimate. All right, let's look at the next one. Let's look here at 10 equals 5 times e to the 5x. So the 10 equals 5e to the 5x. First thing I would want to do is I want to get rid of the 5. So I'm going to divide both sides by the 5. I want to know what just the e is. So now I have e to the 5x equals 2. Well, I just found out, and I just kind of came up to the rule that my exponent will always equal, when it's a base of e, will always equal the ln of both sides. And technically what you're doing is you're doing this. You're taking the natural log of both sides, and these two kind of cancel each other out. So what I know, and I'm going to write it over here, is that 5x equals the natural log of 2. Now if I'm solving it, and I have to solve it by dividing both sides by 5, x equals the natural log of 2 divided by 5. That is my final answer, or again, you can give me the estimated answer. What if I start with natural log of x equals 7? Now what we've done in the past is, well, let's talk about this. Natural log of x is really log base e of x, and that equals 7. Now if I put this into exponential form, e to the 7th equals x. Well, this isn't so bad. E to the 7th I can find. You can first of all leave it like this and say, okay, I'm done, because that's an exact answer. Or you can get your calculator out and say, well, I can figure out e to the 7th, or an estimate for e to the 7th. I just go natural log, take it to the 7th power, and my answer is 1096,633. So you can also say my answer here was 1096.633. Both of them are equally good answers. Both of them I would accept. Again, this was exact. This is our estimated answer, our rounded answer. If in fact you ever have an issue where you have 2 times a natural log, or a constant times a natural log, what is important to do first is just to get rid of that constant by dividing both sides by it. So what we know now is we have the natural log of x, and that equals 2.5. Okay, so technically what you're doing here is you're going to take and make them both have a base of e. This kind of cancels itself out, and so our answer is that our x equals e to the 2.5. Again, it's okay to leave that answer or put it into exponential form. Let's do another one. Let's do this one where we have 4e to the x plus 3, and then it equals 82. Well, our first step is to divide both sides by 4. So that's going to give me e to the x plus 3, because I get rid of this, equals 20.5. So now I can get rid of my e, and my exponent, if you remember, equals the natural log of the value. So when you have an e, you use natural logs. When we have a natural log, we use e. So now what I need to do to solve this is I need to subtract 3 from both sides. So my answer in the end is that my x would equal the natural log of 20.5 minus 3. Okay, and you can kind of, again, find an estimated answer to that, or you could leave it like that. So let's look at these. Let's do some natural logs to solve these equations. Well, in the first example, you might say, well, you know what? I already know how to solve this using logs. I showed you before that the exponent would always equal the log of the value divided by the log of the base. Well, I want to make the point where now you have another option. The exponent can equal the natural log of the value divided by the natural log of the number. Both will give you the same answer. Let me prove that to you. We had 72 and 6. So I said that the log of 72 divided by the log of 6 is equal to a value. And then I could do the same thing with the natural log. It was natural log of 72 divided by the natural log of 6. I'm going to get the exact same value here. So it's the same ratio that we're working with. You still get 2.387 for both values. It's just a different route to get to the same answer. If you have an e, however, that one kind of almost forces you to use that natural log because that's kind of the partner to the e. So if I looked at this problem, I'd have 25e to the x equals 1,000. Divide both sides by 25. Now my e to the x equals 40, excuse me. All right. And so now to say what's my x here would equal just the natural log of 40. And I just have to calculate whatever the natural log of 40 is. We do still have the problems of what do we do when we have natural logs or two values, two bases, and they're raised to an exponent. Same rule applies. And I know some people really struggled with this when we did it on our test, so I want you to kind of pay attention. The same rule applies. Just like before when we took the logs of both sides, I can take the natural log of both sides of this equation. That's natural log here. All right, so then the rule is exponents become coefficients. So I can move this x plus 2 and this x minus 3, and I can make them coefficients. And so what I'd have here is I'd have this x plus 2, and I'd make it the coefficient of the natural log of 6. I'd take the x minus 3, and I'd make it the coefficient, or the front value, of the natural log of 14. And what we would do is we're trying to get our x's together. So I'm going to go ahead and I'm going to multiply through. I'm going to multiply both of these by natural log of 6. I'm going to multiply both of these by natural log of 14. So what I have natural log of 6 times x. All right, natural log of 6 times 2. And they're being added together. So I'm going to write 2 natural log of 6. That's usually how we show that. Here, I'm going to make it equal to natural log of 14 times x, and it's kind of like that. It's kind of, I'm having a hard time of showing it exactly right. And then 3 times the natural log of 14. I usually highlight the fact that it's 3 times that value instead of, so it doesn't look like 143 for a natural log. Now I need to get my x's together. I need to somehow combine this and this. All right. So what I would do is I would just subtract one of them. So I'm going to subtract from both sides natural log of 14 times x. Okay. So I'm going to subtract that here. Natural log of 14 times x. All right. So really what I have here, what's being multiplied by the x, if I combine like terms, is I have the natural log of 6 minus the natural log of 14, and that's being multiplied by my x. Minus 2 natural log of 6 equals a negative 3 natural log of 14. What I do next is I'd add this 2 natural log of 6 to both sides. 2 natural log of 6. Now there's no nice way to add it. We're just going to leave it, and we're going to write it out as negative 3 natural log of 14 plus 2 natural log of 6. And that equals this natural log of 6 minus natural log of 14. Now the same rules apply, that when you have a natural log minus another natural log, they have the same base, or both base e, you can use it and make it into division. So I'm going to say this is really natural log of 6 divided by 14. But now I need to divide. So I'm going to divide both sides by that, because I want x all by itself. So divide both sides.